Welcome to All Out Aviation, the YouTube channel that dives deep into the world of aviation. Today we are focusing on why do airplanes fly? It seems so magical and impossible, but due to the technology of today, the possibilities of flight is almost endless. From the day the Wright brothers flew 120 feet to the American F-35 stealth fighter that can take off and land vertically and reach speeds of up to 1,200 miles per hour. So, let's dive straight into why do airplanes fly. Airplanes fly due to the principles of aerodynamics, which involve the interaction of four primary forces: lift, weight, thrust, and drag. These forces must be balanced and manipulated for controlled flight. Lift, the upward force counteracting the weight of the airplane, is generated by the wings. The wing's shape, called an airfoil, is designed to create different air pressures above and below the wing. As air moves over the curved top of the wing, it travels faster, reducing pressure according to Bernoulli's principle. The slower-moving air beneath the wing has higher pressure, which generates lift. Additionally, the angle at which the wing meets the oncoming air, known as the angle of attack, influences the amount of lift. A moderate angle increases lift, but if it becomes too steep, the airflow can separate from the wing, causing a stall. Weight is the force of gravity pulling the airplane toward the earth. For an airplane to fly, lift must equal or exceed weight. Aircraft designers carefully consider weight distribution and payload to ensure the plane can generate sufficient lift for stable flight. Thrust, the forward force propelling the airplane through the air, is produced by its engines. Jet engines generate thrust by expelling compressed and heated air backward, following Newton's third law, which states that every action has an equal and opposite reaction. Propeller-driven airplanes achieve thrust by using spinning propellers to accelerate air backward, pulling the aircraft forward. Thrust allows the airplane to move fast enough for air to flow over its wings and generate lift. Drag, on the other hand, is the resistance that opposes the airplane's motion through the air. It is caused by air friction and turbulence. There are two primary types of drag: parasite drag and induced drag. Parasite drag comes from non-lifting parts of the airplane, such as the fuselage, while induced drag is a byproduct of lift generation, created by wingtip vortices. Aircraft are designed with streamlined shapes to minimize drag and maximize efficiency. Engineers strive to balance these forces, enabling the airplane to maintain steady flight. Now, that is the basics of flight and how an airplane stays in the sky. There are many more factors that can come into play, you might think, but gliders doesn't have engines at all and a fighter jet has these thin wings. How can these planes possibly fly? Well, let's have a quick look into how these type of aircraft might operate. Gliders achieve flight through their lightweight construction and highly efficient wings designed to maximize lift. Since they lack engines, gliders rely on external forces such as rising air currents, known as thermals or ridge lift, which occurs when wind flows over obstacles like hills or mountains. Pilots of gliders use these air currents to gain altitude and extend flight time. The wings of a glider are long and slender, creating a high aspect ratio that reduces drag and allows for sustained, efficient gliding. By carefully controlling the descent rate and leveraging natural forces, gliders can remain in the air for hours despite having no propulsion system. Fighter jets, on the other hand, are engineered for high-speed performance and rapid maneuverability, which requires a completely different approach to flight. Unlike gliders, fighter jets are equipped with powerful jet engines that generate immense thrust, allowing them to overcome drag and gravity. This high thrust enables them to achieve supersonic speeds and climb steeply, even with relatively small and thin wings. The thin, low aspect ratio wings of a fighter jet are designed to minimize drag and handle the stresses of high-speed flight. These wings sacrifice some lift efficiency for strength and speed, which is why the engine's thrust is crucial in keeping the jet airborne. The thin wings of a fighter jet also play a role in enhancing maneuverability. Their small surface area reduces drag at high speeds, allowing the aircraft to perform quick rolls, sharp turns, and other agile movements. The lift generated by these wings is often supplemented by advanced control surfaces and the jet's powerful thrust. Fighter jets are also equipped with sophisticated avionics and flight control systems that help maintain stability and optimize performance under extreme conditions. In a nutshell, airplanes fly because of the delicate balance of the four forces of flight: lift, weight, thrust, and drag. Through innovative engineering, aerodynamic principles, and powerful propulsion systems, humanity has conquered the skies, allowing us to explore, connect, and achieve what was once thought impossible. Whether it's the silent glide of a motorless aircraft or the supersonic speeds of a fighter jet, every flight showcases the brilliance of science and technology. If you've enjoyed this journey into the fascinating world of aviation, make sure to like, comment, share, and subscribe to the All Out Aviation channel. By doing so, you'll help us continue soaring higher, bringing you more incredible content about the wonders of flight. Thanks for watching, and keep your eyes on the skies.